Have you ever wondered if we could rewrite the blueprint of life itself? This question might sound like science fiction, but it isn't. Welcome to the fascinating world of genetic engineering. This revolutionary field is all about changing the genetic makeup of cells. It's like being given the keys to the very building blocks of life, with the power to rearrange, delete, or even add new components. Genetic engineering employs a set of advanced technologies to transfer genes within and across species boundaries. This enables us to produce improved or novel organisms, from crops resistant to pests, to animals with enhanced traits, and even potentially to humans free from genetic diseases. Imagine being able to design life to our specifications, to solve problems, and to create opportunities. It's a thrilling thought, isn't it? But it's not just a thought, it's reality. Genetic engineering, in essence, is the direct manipulation of an organism's genes. And we are just beginning to unlock its full potential. At the heart of genetic engineering are tools as precise as a scalpel, yet working on a microscopic level. Among these, one stands out, a revolutionary gene editing tool known as CRISPR. This remarkable technology, short for clustered regularly interspaced short palindromic repeats, allows scientists to edit the DNA sequences of organisms with unprecedented precision. Imagine DNA as a long string of code. CRISPR works like a pair of molecular scissors, able to cut at specific points along this string. But it doesn't stop there. Once the cut is made, scientists can remove, add, or replace certain sequences, effectively rewriting the genetic code. This is akin to editing a sentence in a book, where you can remove a word, replace it, or even add a new one wherever you choose. This level of control over the genetic code was unimaginable just a few decades ago. With these tools, scientists can alter the very fabric of life. Imagine a world free of inherited diseases, or crops that can withstand any pest. That's the promise of genetic engineering. It's like we've been handed a magic wand that allows us to manipulate life at its most fundamental level. But with great power comes great responsibility, and there are both thrilling possibilities and sobering concerns to consider. Let's first marvel at the potential. Consider the realm of medicine. Genetic engineering could potentially cure devastating genetic diseases, from cystic fibrosis to muscular dystrophy, by repairing or replacing faulty genes. It could also help us understand and combat complex conditions like cancer, where multiple genes are often at play. Then, there's agriculture. By manipulating the genes of crops, we could potentially increase yield, enhance nutritional value, and create varieties resistant to pests, diseases, or harsh climatic conditions. It's like custom designing nature's bounty to feed a growing world population and combat the effects of climate change. But as we stand on the brink of a new era, we must also confront some hard questions. The power to manipulate genes raises the specter of unintended consequences. We're dealing with complex biological systems that we don't fully understand. An alteration intended to do good could potentially cause harm if it interacts in unexpected ways with other genes or environmental factors. And then there's the ethical minefield, the possibility of creating designer babies, where parents could potentially choose their child's traits, from their intelligence to their eye color, is a contentious issue. It's a slippery slope that could lead to a new form of eugenics and widen social inequality. Genetic engineering holds immense potential, but it also presents us with challenging ethical questions. It's not just about what we can do, but what we should do. As we wield this powerful tool, we must tread carefully, ensuring that we use it for the benefit of all, and not just a privileged few.